Okay, so let's move into the worksheet number 7 from lecture number 7. As you already know, lecture number 7, we basically discuss about atomic structure and also how electron, proton, neutrons going to be stay on the atom. And then we discuss little more definitions of like terms, scientific terms that we define: element, molecule, compound, mixture, isotopes, and those kind of things. And then finally we move into the density, right? So then we discuss about how the density will change by changing mass and the volume, and also we discuss about the elasticity a little bit. Those are the things that we discuss, right? So I think in this section I'm going to move into the worksheet problem very quickly, because those all are kind of conceptual things, that there are no lot of formulas and things. It's like conceptual chapter for the get and scientific words and terms that you need to get understand about the materials. So usually atomic structure, as everybody know, that we have neutron and proton sitting inside of the atom, that is we call it as a nucleus, and then electron is the one that will keep orbiting around the nucleus, right? This is the basic definition or basic structure of how the all the matters created by using atoms, and atoms will be behave like very tiny particle that will behave like this structure. So now everything, all the materials, how they made up by using atoms, and this electron is very important particle that can move, jump from one atom to another atom, create different molecules, and those kind of things stick together because of especially this electron. In addition to that, we know that electron is light particle, right? Lightest from these all particle, because it mass will be much smaller than the other two, right? Mass of the electron is equal to 9.11 10 to the power negative 31 kilograms. But mass of the proton is around 1.67 times 10 to the negative 27 kilogram. That will be exactly same mass for the neutron, right? In addition to that, electron has charge, right? It is a negatively charged particle that will be equal to 1.602 times 10 to the negative 19 coulombs. It is a negative for the electron, but proton has the charge that has the exactly same charge, but it is a positive charge, right? So in terms of size, electron is the lightest one, as we discussed, right? And but there is a mass number, and we talk about those also. Mass number is basically number of proton plus number of neutron, and then we have atomic number. Atomic number is the symbol Z for that. It is number of protons, right? So review the lecture part for those, and later on we discuss about terms, as we discuss isotope. Isotope is basically same substance, but there are different number of neutrons. Because of that, they call it as isotopes. And then we had the iron. Iron is called it as the charged particle, which can have positive or negative charge. And then compound, molecules, mixtures, those are different terms. Sometimes people exchange those terms according to the concept that we need to discuss. And in addition to that, we discuss about definitely the density, right? Density of the material is defined as mass over volume, right? So definitely you can see, if I measured it by grams and volume by centimeter cube, that will be the density units 4, not in SI units, but that's the usual density units that we use for the calculations. And again, density will increase when the mass increase by keeping constant volume, but density will be decrease when the volume increase if you keep mass constant. Those are the important steps inside this formula. Right, so in addition to that, we move into the elasticity a little bit. That's where that we talk about the Hooke's law, right? So elasticity, especially the Hooke's law, right? When I have the spring, this spring will be staying somewhere here when I hang the mass M, right? But if I keep adding the mass, then this spring going to be stretched, and then this stretch distance are, you have x distance displaced, then there is a force, this force acting on the spring, we call it as the spring constant times the displacement. Spring constant is a constant that is given for the spring. Okay, that's depend on some other parameters that we did not talk in your class. But important thing is the force applied on the spring is proportional to the displacement of the spring from the original position. So those are the main part of this chapter that we discussed. Okay, so now let's move into the question number 1 directly. I know that I explained those things already in there, but explain electron, proton, and neutrons. Which of them has the smallest mass? Which of them is smaller in size? Which of them is neutral? So you can define electron by using in your words what the electron is, and then proton, right? And then neutron. Okay. In simple words, I'm going to define it as electron is the negative charge particle moving around the nucleus, in my words. Moving around the nucleus. I would say proton is a positive charged particle, but sitting inside nucleus. Okay. Neutron is a neutral particle. Neutral, that means no charge. Neutral particle, but sitting inside nucleus. Okay, that's my definition in words. So now which one has the smallest mass is my next question. This is first part. Next question is the smallest mass electron. And next one, which one then is smaller in size? Smaller in size. Sorry, size also electron. Okay. Last question is which one of them is neutral? Neutral is neutron. Okay. I think that's enough for that question. Okay, let's move into question number 2. So describe element and molecule. Okay, so now element is the periodic table. If you think about the elements on the periodic table, those are the elements. But molecule can be combination of 2 or more atoms bonded together, right? So we describe those things. So let's write it in words. First one is element. I would say in my words, I'm going to say composed only one kind of atom. That's we call as the element. The periodic tables, the elements that you have, those are called as elements. And the molecule I'm going to say two or more atoms bonded together. We call it as molecules. They can be different atoms, they can be the same atom. It doesn't matter, that we call as a molecule. Okay, maybe same atom or not. Maybe same atom or not. Both are, we call it as molecules. Okay. And how atoms combine to form molecules? So what do you think? Atoms combine to make molecules by sharing electrons. Electrons, by sharing electrons. Okay. That's how they bonded. Okay, number 3. Investigation of atoms sequence alone. Each horizontal row of the periodic table shows that atom decrease in size, mass, or atomic weight. So which one is correct? So go back to my lectures. I'm talking about the periodic table. Periodic table, the size of the atom is decrease, not always, but it is decreasing when you go to the left, but going down, atomic size is increasing. Okay, size, usual pattern, atomic size. Okay, but the mass, you know that the mass is keep increasing when you go to the left, and also increasing when you go to the down. And the atomic weight, again, it is a mass, so it will also increase in both directions. But investigation the atoms within the horizontal row, the periodic table shows that the atoms decrease in size. Other both are increase, go to the right and the down. Okay, so that's easy. And number 4, if you add or subtract proton to or from the molecule, the nucleus of an atom, what do you produce? If you have an atom, if you add the proton, or if you subtract the proton, or you add the electron, you subtract the electron, what will happen is it will create an ion, right? Will create an ion. So create positive or negative charge. Create positive ion. Create positive ion when you add proton. Okay. So in other way, when you add proton, or you can say you release electron. Same thing, adding proton or releasing electron. Release electron. This both cases, it will create a positive ion. So now create a negative ion when release proton, a proton, or many, doesn't matter, and when, not why, when, and also add electron to the atom, will create a negative ion. That's how it will create negative and positive ions. Okay, number 5, the atomic number of an atom is defined in terms of electron, proton, and neutrons. I clearly discuss about this. Atomic number, we use the symbol Z. That will be number of protons. Since it's the atom, that also equal to number of electron, because in the atom, number of electrons and protons are equal to each other in atom. Okay. Atom has equal number of electron and proton. Equal number of electrons and protons. Because of that, number of protons of the atom or number of electrons of the atom, we can call it as the atomic number. Okay, so now let's move into the number 6. Number 6 is talking about what is isotope. Do they have same number of electron, proton, neutron, atomic number, or the atomic mass? So what is the isotope is, as we discussed? Isotope, we call it as different atomic mass, but what is the isotope is number of neutrons are different. Different on the same substance, same element, I would say, same element. Same substance, they have a different number of neutrons. Those we call it as the isotopes, right? So now that's the definition. And do they have same number of, yeah, they have same number of neutrons. Okay, so now let's move into the next question. A nucleus with the atomic number 44 and mass number 100 must have how many neutrons? So you know that the mass number equals number of proton plus number of neutrons. So protons and neutrons are equal. You can say number of protons plus number of neutrons, or number of electrons plus number of neutrons is the same thing. So atomic number equals number of protons, right? As we know. So now number of protons, I'm going to write it here. Number of protons equal 44. Then same way you can write number of electrons also 44. Now number of neutrons will be equal to atomic mass number minus proton, right? So mass number is 100 minus 44 will give you number of neutrons. Number of neutrons equal 56. Okay, it's simple. And next, move into the number 8. Which of these has greatest density? So now we're going to move into the density information. Density equal, as we know, density we use the letter rho, that the Greek letter symbolized for the density, equal mass over volume. Okay, mass over volume. So now it says 1 gram of lead and 1 gram of aluminium. That means they have the same mass. And 1 grams of concrete. Let's forget about the concrete in here. We don't want the concrete. Okay, because concrete is not in the periodic table. Let's take 1 gram of lead and 1 gram of aluminium. So now if you go to the periodic table, lead is the heavier than the aluminium, right? So usually if you take the sample of lead like this and sample of aluminium like this, lead and aluminium, right? So now, although in sample wise they are same volume, usually lead has a heavier mass. This is heavier. That's why in periodic table, lead is sitting bottom of the periodic table, not on the top, right? Because it is a heavier element. So now, but here the information is both has the 1 gram. Both has 1 gram, but since 1 grams of lead is in volume, should be smaller than the volume of the aluminium, because you take the heavier object but you select the 1 gram. Then you have 1 gram may be this size for the lead, but aluminium 1 gram may be this size, because volume of the 1 gram of lead is smaller than the volume of the 1 gram of aluminium. Since this one is the constant for both, whichever one has the smaller volume, that means lead. I'm going to write volume of lead is smaller than volume of aluminium. Volume of lead is smaller than the volume of the aluminium, same 1 gram mass, right? So now what that means? What that means is you have the lead is less volume. When V goes down, that has the higher density. That means the which one has the greatest density is lead. I hope you understand that. Okay. I can ask the same question by giving you the same volume of lead and aluminium. When you give the same volume of the lead and aluminium, then you need to think about the mass. If you take the 1 centimeter cubic lead and 1 centimeter cubic aluminium, then 1 centimeter cube lead has a heavier mass. That means mass is increasing, then density is increasing. That you need to think from your side. Okay. Okay, let's move into the next one. When given mass of the water freeze, it undergoes decrease in volume or density, right? So that's, you probably observe that in real life. So it will, when you put the water bottle, we'll say you have a water bottle, you do not fill it up, but you're going to fill it to somewhere and put it into the freezer. After it freeze, what you're going to see is bottle is stay on the same size, but you have the water volume is increased, right? So now when water freeze, what happen is volume increase. Volume increase. When volume increase, what will happen to the density? Because density rho equal mass over volume. When volume increase, density decrease. Then decrease in density. Okay, let's move into the number 10. So now number 10 is asking what is the elastic material which is more elastic from steel or rubber. So now elastic material is basically which obey the Ohm's law. Elastic materials obey Ohm's law. I'm sorry, Hooke's law. Oh, I'm very sorry, Hooke's law. Hooke's law. Obey the Hooke's law, right? So now what is the Hooke's law is? Force equal K times the displacement, right? That means if there is a spring that will stretch because of the mass, that stretch distance is proportional to the force that you applied on the spring. That is what the Hooke's law is. So now elasticity is defined as how much it can come back to its original place after it displays some amount. So now if you take the rubber and the steel, you know that the rubber will stretch, but it will never come back to its origin, right? Rubber always has a small displacement after you stretch it. It never will be back to earlier condition. Because of that, rubber is less elastic than steel. But if you are able to stretch the steel, it will become back to original position definitely. Because of that, steel is more elastic than the rubber. Steel is more elastic than rubber. Okay, so let's move into the question number 11. A 10 centimeter long spring extend 12 centimeter. What that means is you have a spring, right? So spring stay in here, right? So this is equilibrium, and when you add 1 kilogram load, right? When you add 1 kilogram load, it's going to be stretched X amount of distance, that X equals to, see that 12 and 10. So originally this is 10 and this distance is 12, not to the scale, but then 12 minus 10 is this displacement of the spring, 2 centimeters, right? So now what you're going to do is you're going to add another 2 grams. That means total mass, you're going to add these 3 kilograms. Then definitely this spring is stretched more. But how much more it stretches, we can find it by using spring force is equal spring constant times the displacement, right? That means force is directly proportional to the displacement. What that means, if I apply 1 kilogram, this will say it displays 2 centimeters. Now, if I do 3 kilograms, that means 3 times of the 1 kilogram is 3 kilograms. That means this will display 6 centimeters because force is proportional to the displacement. What that means, after I add 3 kilograms, my spring is going to extend 6 centimeters. So this is displacement of the spring displacement. That means X, right? X is now 6 centimeters. But make sure that you again answer to the question it is asking. What would be its length if 3 kilogram suspended from it? Now, this is displacement. Originally, it was 10. So now, new length will be 10 plus 6, right? That will be 16 centimeter. It is the answer for the question. So now question can ask what would be its length if 3 kilogram loaded, or it can ask what is the displacement after 3 kilograms added. So for that, it will be 6 centimeter. New length will be 16. Okay. So make sure that you answer to the question given, because those questions I add all the informations for you to understand, but question may be part of that. Okay. Number 2 is, so according to the Hooke's law, if you hang by a tree branch and note how much it bends, right? Then hanging with twice the weight. So you have a branch like this, right? So you're going to hang some weight and then you check how much it bend, this kind of bending. Now you're going to add twice of that mass, then how much it will bend is the question. So now you know that because force is proportional to the displacement, because of that, if you double this, twice of F will double this also, twice of X, right? So normally twice the bend. Because of the reason why, question is why, because of the force is proportional to the displacement according to the Hooke's law. Okay, so number 13 and number 14. Okay, so number 13, there is an iron nucleus with the atomic number 26 and the mass number 57 must have how many electrons, how many neutrons and protons. Okay. So iron is the molecule, so it's given atomic number. You need to remember that atomic number is number of protons, right? And mass number is number of proton plus number of neutron, right? So now how many electrons? Number of electrons equal to 26 because number of electrons and number of protons are the same. Number of neutrons will be mass number minus number of protons. So that will give you 31. 31 number of neutrons. Okay. So now let's move into the next question. That's the last question. So we have, we're going to compare the density of 1 cubic. So see that what is given, we did exactly same question earlier, but for the lead and the aluminium, right? So there is 1 cubic volume of iron to lead is the one that we're going to compare. They have same volume, that's important, and has an atomic number 82. Atomic number 82 for the iron. So iron, that is the symbol, periodic table element symbol for the iron. Iron has atomic number, that means number of protons. Number of protons equals for the iron 82. And mass number, that means number of protons plus number of neutrons equal 247, right? So which one has greater density? None of these matters. Only matters is actually the atomic, the mass number. Mass number 207 of the iron. But you remember that lead has basically lead I did the earlier somewhere. Okay, this is for the lead actually, not for the iron. That's what I did the mistake. Okay, this is for the lead. We use the symbol PB for that. Let me. Okay, so let's move into the last question. Last question is asking you to compare the density of 1 cubic volume of iron and lead, right? Iron and lead. Those are the symbols in the periodic table for the iron and the lead, right? So we have the information about the iron in the question number 13. Okay, question number 13, there is the information about the iron. You see the mass number is 57. My mass number 57 in here, see, right? And for the lead, mass number is 207. What that represent to you in atomic, in periodic table, that means lead is way forward direction than the iron in the periodic table. Lead is the bottom element, that means it is heavier. That's what it means, right? So this is heavier. So now what the important information here, both of the material has the same volume. This one has the same volume, this one has the same volume. You can think the piece of the volume, they are the same, right? But since lead is heavier, if you take the mass of these two pieces, although in volume is same, mass of this for the lead is greater than the mass of the iron. Mass of the iron. Now what will happen to the density? So density equal mass over volume. Because of that, whichever has greater mass should have greater density, right? Which one has greater density? That means answer is lead, because lead has greater mass than the iron if you take the same size of the piece on both material. Okay, let's stop here.